Okay, before we get into today's content, I just want to make some quick announcement. First, regarding we had a meeting. Finally, I met with both TA, and then we discussed how to work to share the work collaboratively. What's going to happen is that for any discussion, is always started the Wednesday discussion, which is today, is the first discussion session. So it's Wednesday, Friday, Monday. So there is a content for like a week by week. What we plan to do is the following. The TA or me will actually provide some kind of content related to that particular week's topic. For example, this week's topic is going to be homework assignment number 1. And then for Friday and Monday, that you can actually watch that recorded content, but then there will be one of the TA or instructor be there. And then we will be able to, based on that content, to follow as any question you have, any problem. So we kind of hybrid using discussion as a way to deliver some material which is related to your homework or project or midterm exam, and yet we use the rest of the time as a way to handle any question you might have. And in terms of room, what I realize now, I'm actually in the process of doing this. I realize this room is actually available 1 hour after our lecture, which is the discussion time. So I actually feel it's better for us to use this room. Number one, you don't have to walk over there. I don't know how far it is. I never did that, by the way. And the second thing is that this room allows everybody, if there is something which for your schedule, you cannot make it to whatever session assigned to you, and you can always pick Wednesday or whatever session, because we try to do that. Okay, that's just for the discussion. And we have 2 TA. One is Regex. Regex, are you here? Okay, he should be here in a moment. So Regex will be handling homework 1. And John Chapman, the other TA, our new TA, is going to handling the tutorial for Unix environment. For example, Makefile, how do you do WSL, Windows subsystem for Linux, and those kind of tools that you need to use in order for you to accomplish the work this quarter. And that's just for right now, homework 1, and for the tutorial to bridge the gap you might have, because some of you never use Unix. So we want to make sure that everybody get covered to learn a bit of Unix at the beginning. And homework 2, for example, John Chapman will be the leading one. So I'm actually working with him right now for homework 2. Okay, just get started. All right, so that's just logistically make announcement for that. For office hour, for then, they're going to announce their office hour. All right. And for me, right now, I'm actually having 2 office hours. But yesterday, I actually missed it. Yesterday, for some reason, I have a 3 meeting back to back, and then I forgot to send the announcement. So my office hour is Tuesday afternoon, but Friday afternoon, some of the students come to me saying that is conflicting with some of you taking discrete math. How many of you actually have that conflict? Okay, a few of you. Let me ask quick to just get a sense. I'm actually planning to move the Friday office hour from the current time to much earlier, 11 a.m. Would that work? 11 a.m. Okay, so my office hour Friday will be 11 a.m. My office hour will be by default on Zoom. So it's actually easier for you to just call it in, because my office is kind of small. If a lot of people show up, and it's going to be, but later in the class, when we get into the final project, I'm actually has a lab which can host about 20 people. And then so I can actually invite more of you come here. So let me actually just share with you the trade-off. When I have a Zoom, it's easier to put students into different breakout room. The same question breakout center there. But if you can imagine that sometimes there's just way too many students, especially before the homework due. So usually not everybody can be addressed immediately. And sometimes, even though the office hour allocated for 1 hour, it can be easily, some of us will stay there for 3 hours, especially when we get closer to the final, for the sum of the due date. So I will be thinking about how to more effectively handle that, such that we will be able to support as much as, this is a big class, that's usually the challenge. Okay, all right, having said that, I'm actually going to tell you what I'm going to do today. So today, from 3:10 to 4, from now to the end of the class, I'm actually going to talk about homework assignment number 1. And the thing is that today's discussion will be continuation of this, because I don't believe I can handle this based on my talent about dragging things too long. I definitely can use a second hour, but I will record both of this. I will publish all the unpublished video as soon as possible so you can see what's going on. So now let's get down. Before I get to the topic I want to cover, any question? Okay. Yes, please.
When will the other lectures be available on YouTube? Like,
Yeah, the last 2 lecture, right? Yeah, I will upload. I just, when I go home, I want to relax. I forgot. Yeah, but I will. I need to do that. It's my plan. Yes, on the back. All right, thank you. Yeah, please.
Just to confirm, the homework assignment number 1 is due on the 28th, right?
Yes, October 28th. Yes.
Okay, so will that be changed on Canvas or something?
Yeah, I can probably change that. Okay, that's a good question. I forgot to mention that. So some of us will be able to finish the homework very early, but some of us are actually transfer students, especially. They need to catch up a lot of things. So last quarter or last time I taught the same course, what I did is I did 2 different deadlines. It's confusing. So for me, it's just the first homework only. We actually it's just October 28th. Everybody got the same time. Okay. Does that address your question?
It does, yes. Thank you.
Okay, thank you. Yeah. The content of the discussion session will be recorded, but as I mentioned earlier, the discussion is actually going to be like extended for office hours. So for example, I'm helping one student solve a problem. That particular portion will not be recorded. Yeah. Okay. However, that's a good question. I usually record my office hours, especially when I address an issue which I think is important, is a kind of general interest to the rest of the class. I will actually record that. Okay. Yeah, thank you. And all of you, please remind me this quarter when you feel that this content has a greater interest to that moment, then we will record it. I mean, I will be very sensitive about some of the material, privacy issue, but other than that, we should be sharing as much as we can. Yes, please.
I'm sorry if you mentioned already, but Monday and Friday discussions, are they also put in 5 days?
Yes. Yeah, that's it. Yeah, that's because you probably for the Wednesday session, but the thing is that we have a 3 discussion hours. Yeah, we'll use all 3, like both for the content. So let me, that's a question I want to address a little bit. For example, I said we actually record the content for Wednesday. Wednesday is always the first one. And the thing is that for students want to attend Friday and Monday, we expect you to watch that video. And we will upload that video immediately after Wednesday. So you can actually watch that content, and then you can actually just come in to discussion. Discussion here means that just question answering, yeah, to address that issue. Okay. All right. Any other question? I really appreciate all the questions you asked because I think those help us to communicate better. Okay. All right, we're going to look at the Wordle. And there's two purposes. There are two purposes related to this homework. And the first, of course, just have some fun. To actually play a game, to actually try to write a program, even though it's not that mature, but it's actually trigger us to think about strategy. I mean, writing program, algorithm is always about strategy. I mean, how do you actually deal with it? So that's one perspective. The second perspective I really want to use this is an opportunity for us to kind of refresh what we learned from the previous course or realize there is something which is you never learned. And so we took this opportunity to actually try to make sure. Am I recording? Let me just double check. Yeah, it's a recording. Okay, good. All right, so that's what we want to do. So first, I'm going to talk about strategy. I don't know how many of you are not familiar with this game called Wordle. Okay, some of you. Let me just give you a 2-second advice. Go play it. You will learn that. Or the simplest way to say it is that you essentially provide the computer is randomly generate a 5-letter word. And that word must be coming from a database of a legitimate word. And what you want to do is that you actually start to guess what that word is. And the way is computer is going to give you some information about every single word, that 5-letter word you put in. The number one is going to tell you that which of the 5 letters you actually guessed it right. And which letter is not in the word. For example, a word could be float, F-L-O-A-T. So when you actually guess a word, you guess a word scare, S-C-A-R-E. Then S is actually not in any of the letter of F-L-O-A-T. So it's going to tell you that particular letter is not there. And then you actually going to distinguish whether the letter that indeed in the word was that in the right position. So it's going to give you, in the program I show you, it shows a pound sign, means that you not only hit the character, you actually hit the position. If it show you a little o, lowercase o, that means that that letter is in the answer, but not in the right position. So you can think about this is a strategy game that the system is going to reveal more based on the quality of the guess you have. And then you can do this a few rounds. And eventually you kind of, if you like me, when I play, I mean, I'm not kidding about this. When I play Wordle, I do this and then I use Google. I said, if you do Google, say, which 5-letter words contain this letter, this letter, this letter, and then Google gave me a lot of things. And then I start to do that. So that's my strategy when I actually play real Wordle. Okay, so that hopefully give you some idea. So you have about 6 rounds, 6 chances that you can actually get it. By the way, for homework assignment number 1, we can make it a lot bigger. We don't have to do 6. For computer, because they're not as smart as human. You can actually set it to be 60. That's fine. 60 or 100, whatever. Because that will make your strategy more flexible. If you want to give you 6, it might fail. Okay, so you have that flexibility to change that, to make a multiple round. All right, so that's actually number 1. So number 2, I'm going to tell you is that Wordle is, again, a lot of those is, of course, related to your capability to know the vocabulary. Of course, that's very important. But from the computer perspective, Wordle is really, again, about elimination, the wrong candidate. Okay, so let me actually try to run this program a little bit. Can you see my, yeah, you can see my screen, sorry. return. Okay, by the way, I want to show you that some of you actually recognize that there is one version of the program that's actually in GitHub. That was actually by the original author of this program. And when he developed this program, he developed in a window environment. So now you're actually going to see that why I want to make sure you understand Unix is that Unix and Windows, they are somewhat similar, but there are some critical differences. One of the major difference is actually slash and backslash in terms of when you accessing a file. So in Unix, slash is the way to specify for you to travel through the file system in the terminal. But in window environment is backslash. So the program was written in the backslash case insensitive fashion. Of course, when you compile it works, but when you run, it cannot because that does not help you to access to the file. Okay, so let's actually take a look at this file. This file is called Wordle. This is Wordle. This is the file that's actually from the GitHub. You see here, they have a backslash. When they try to open this two file, you can see that they actually separate into using lists, backslash, backslash. So it means that they're actually following the backslash tradition. So in order to get this program to work, the second thing is case insensitive, is using all capital. So in order to make this to work, you have to get rid of this and then say list. You see, I changed that to be slash instead of backslash. If you change this to, then essentially your program will be able to run correctly. And that is the difference between the GitHub and the Canvas. So I actually changed that and then so it will work, okay? So let me actually show you. Let's try to run this program, try to compile this program first. Okay, I'm actually using GCC compiler that program called Wordle.c, and then I just run a.out. And in a.out, I just say new. And then basically I'm in the system saying that, well, you can have your first guess. So my first guess, I will say, let me actually pick what kind of, I mean, for those of you who actually play Wordle, you must know which word you want to pick. Yeah, which word? Earth. Okay, yeah, cover 3 vowel already, right? Or 2 vowel. Okay, so I type Earth. Okay, so now you can see that it's actually telling you that the word, wow, this is pretty good because this one has 2 words that's actually match, not just match, 2 character is match, not just match, the position is correct. So the word, the final answer must be EA something. And then you have the other 2, which is saying that RT is there, but they're in the wrong position. And the only word is not there is actually how do I say that? The underscore you don't have a H over there. Okay. The second letter has to be A, right? So you're saying that EA what? EAT.
Yeah, and then
Okay, that will work. Ether, let's see. Ah, you win. You're smart. You're good at this. Okay, good. All right. So that's the way to play, right? I mean, so right now we just need to translate that into a computational strategy. I mean, by the way, let's try to play again. Because usually, give me another word. Anybody want to give me a 5-letter word?
Race.
Race. Okay. RAISE. Okay. Why is invalid input? Oh, no, I have to type new first. Okay. It's only the R make it, but AISE didn't make it, right? R make it, but AISE didn't make it. All right. So anybody want to give the second word? In the back.
Prime.
PRIME, like this. But there is already I, we know I is not there, right? Hydro, like this? Okay.
R not.
Okay. All right, let's change the deadline. The deadline is tomorrow. Okay. Not October 28th. You guys don't need that much time, okay? You're much better than me. All right, just tell you that my best record is 3 guess. Okay, my best record is 3 guess. I never get two. I mean, it's just, yeah, gosh, you guys are unbelievable. All right, okay. All right. I want to show some bad examples. So I can show how you write a program to be not so smart and then to be eliminating, but no, that's not. Okay, let me try again. I want to get something which is okay. I usually start with the word irate. And because it has like a 3 vowel, and then with the most common letter R and T. And the other word I sometimes use is like snore or something like that to cover that. So this one, they still have 3. Wow, today I'm actually really unlucky because sometimes when I do this is all underscore, means that none of them actually match. That reduce immediately to a few letters. Okay. All right, so now this is a program. I hope you get a sense about how this works. So I'm going to actually show you a different program. This program is actually, let me compile it first. This is the program, kind of. I will actually publish this program. I will show you how I did this. And then we can actually, this is not a complete solution, but it gives you some module to help you to do elimination. Okay, let me actually try to run this program first. Okay, so I'm actually going to have a game. Okay, so this program is actually doing some kind of candidate elimination. So it actually realized that there is a magic, okay, internal magic, which I'll explain you later. It's a little bit cheating. But I have a way to do quick elimination. And in this particular case, I actually realized the final answer must be one of the 2 words. Haven't or haven't. Because I have a way to, I already guess I don't know how many times. And then I realized I can eliminate a lot of words. And such that I only know that it needs to be this 5-letter, and then I have that. So that's not just assuming I actually will get, say, vapid. Okay, I win. It should be the other word, I thought. Let me try again. Okay, this is a 3-letter. MEOUS, MOUES, MOUSE. Okay, so I'm actually, to be honest with you, based on knowing the system, I know the answer must be mouse, MOUSE, but I'm actually going to do MEOUS. Okay, so basically, you see that I actually has only the first letter is right, the rest are all different, right? So this is the way about elimination is that I actually have about 12,000 words. That's actually 5-letter words. But based on the guessing, my program can automatically reduce the candidate to a very small number. And based on that small number, then if you actually have a list of words with this three, then at most it's the three guesses, but you probably have a different way to actually check on the position, because I haven't actually fully utilized the position of the word. And then you will be able to actually quickly realize the word is mouse. Okay, so something like that. Let me try another one. New. Oh, this one doesn't have, it actually reduced all the way to bunch, because BUN, this means that BUN, there is no word that's actually in the system can include this exactly this 5 letters except bunch. That's why the candidate has only one. Okay, so most of the word, the 5 letter or whatever 4 letter, they're actually going to reduce from 12,000 to very small number. And then you can actually just exhaustively try all 5, or you can actually just develop other strategy. That's your choice, okay? So let's actually look at the program. How do I actually do this? What?
Can we like this in the homework?
Yeah, you can. I mean, this is the way okay. The way I actually just show you how I do this, but the thing is that in your homework, you're actually going to, whenever you guess, that's actually count a guess, right? I'm actually, for example, you eliminate, how do I actually eliminate a bunch? Is that I have, if you think about this, if you can come up with 5 5-letter words, or even 4 4-letter words, they are not overlap in any character, then essentially that covers 20 characters. Do you know that totally how many characters we have? 26 characters. So essentially that 20 character either already cover that 5-letter, or is actually, you know, which one is actually going to be eliminated. So the first stage of the game is that how do you actually eliminate as much letter as possible? And then you have a small number of characters, say not 5, but 6 or 7. And then you go through the database to search for each of the words that's actually contained that 6 or 7 characters. And then essentially, so there are 2 stages. One stage is elimination, right? And the second stage is just filter out from the 12,000 words. Does that make sense? That's actually, for human being is hard, because we have to go through the file of 12,000 words to do that. But for computer, that's actually very easy. We just look for all the words and then quickly eliminate. Any question? Okay, let me actually go through the program right now. By the way, I'm going to send this program to you. It's not fully developed, it's not a solution, but it contains segment of code. That's actually help you to say, how do you open the file? How do you do like a comparison and things like that? There might be better way for you to do that. I'm actually just do a very quick hacking to get this to work. Okay. The most important thing in my data structure is the 3 line. I add the 3 line into this. There are 3 letter, there is a function called filter words. And the input of that filter words is a pointer to an array. So what I did is I create an array, I call that impossible array. So it means that impossible array is actually remember all the character. That's actually impossible to be the word. So I kind of, through my program, through the guesses, I kind of build up and try to make sure I have that array. And also I have the second number called impossible current. Impossible current essentially remember how many character currently has been eliminated. That means they are in the impossible array right now, okay? So initially, impossible array has nothing, and the impossible current is going to be 0 initially. And the thing is that we're going to build that up, And then once you build that up, you actually call this function called filter words. And the input is going to be that impossible array. And for you to actually decide which word will remain in the system. So now I'm actually going to the filter words to see what that is. Okay, so here is the function I call, no, not this one. Filter words is here. So you see that I'm actually taking one argument, the impossible array, and then into this function. And then I try to basically decide whether this word is actually okay or not. Okay, so now I'm going to tell you this code, and then hopefully to also please ask question if you are unfamiliar with the C syntax I'm using. Okay, anything you can ask at this moment. Okay, the first one I'm going through this. The first line, of course, this is the declaration. I declare a few variable. One is ing. That's typically in C. When I do a loop, I need a few index variable. That's why I define ing. And then I have a flag, which is basically is a Boolean. I should actually define this as a Boolean, but I just use flag, use integer right now. So the first things I did, let me go through this code, is actually check whether the impossible is null or not. So essentially in C program, especially, I kind of has been a victim for too long. And so I realized I need to write the code to be a little bit defensive. So anytime somebody passes me a pointer, I always check. By the way, this is a good habit for all the C++ programmer because of the something called pointer. It is actually sometimes people just send you a null pointer, and which is really going to causing the system to malfunction. So usually what we did, the first thing is I got any pointer, I want to see whether that pointer is a null pointer, because I check that before I dereference a pointer. That is actually a very important thing for you to do as a C programmer or C++ programmer. Java programmer, you don't need to worry about that, by the way. Python programmer, never need to worry about that. But unfortunately, write a C program, we have to do that. So we check whether that's null or not. If it's not null, then I actually do something called string length. String length is basically because in C, character star means a pointer to a character. It also means it's a character array. It also means that character star is a string. That's why if you never write C program, you probably feel really strange that in C, we actually mix a few concepts in the single representation. Like this is one of the case. So in this case, it's a pointer, but it's also array of character, but it's also what is a string. And in C, the string is a bunch of character and then end with a binary 0. That's what we call delimiter in C. Okay, for those of you who took ecs36b, you're probably familiar with this concept already. So I use the string length to decide how many characters I have before I hit the end of the string, which is a \0, and that's called string length. And then that gives me an integer I call character count. And then remember, I'm a C programmer, always check. So I say whether the character count is greater than 26, because I know if it's greater than 26, I know that's actually not right. So I'm going to just return null. Okay, so now I actually have that. So now I'm actually going to produce a lot of words that's actually based on the candidate I have. So essentially, I actually using malloc malloc is memory allocation. Let me check for those who actually took ecs36b here in C. Have you learned the concept malloc and free? Yeah, dynamic memory allocation. Okay, great. That's great. Okay, that is one of the harder concepts in C programming. It's called dynamic memory allocation. In Java, in Python, you don't need to worry about how much memory you allocate. You just say, I want this, they will automatically handle for you. But C is like, they give you all kind of low-level control. So you can actually control the amount of memory the system is given to you. And that is actually a function, a library function called malloc, memory allocation. And then you allocate the memory and you also free it. So that's why when you have a malloc, you need to have the other corresponding free when you finish using that. That's called dynamic memory allocation. That's very unique. Only C programming language has it. Okay. All right. Just remember that. So I allocate the memory using the function malloc. And now I'm going to tell you a little bit about file system. So the file already open. By the way, in the code, you already have an F open. Let me just tell you. Okay, you see that I actually modified the code, right? The original source code, okay, I actually keep the original source code. Original source code is list, and then I changed to list. But nevertheless, both of them using this function. This is actually a library function, but involves what we call a system call, called fopen. Fopen is that you open a particular file. And just to let you know, you see that fopen, there are two arguments. The first argument is the name of the file you try to open. The second argument is what we call the mode you're open. So that mode is what? Is R. R means you open this file for read only. And if you put a W, means that you open the file for write. So this is actually very useful because file I/O is actually, we're going to use this file I/O a lot later this quarter. So it's good for you to understand the concept. You actually, first you open the file, you open this file for read or for write or for A. The mode could be R, could be W, could be A. A stands for append. You can actually, means that you open the file, you actually S stop at the end. Okay, and so that's the fopen. Okay, so this is the fopen. You open the file, all.txt, and you actually have what we call file handle is fp_all, file pointer all. Okay, so basically fopen is a call that will help you to open the file in the mode you want, and then return a handle, which is called fp_all, which now you want to deal with the file, you deal with this pointer called fp_all. Just show you what the type of fp_all. The type of fp_all, declare, sorry. You see that? fp_all is defined here, is actually specified, there is a type called file. And then with a star means what? Is a pointer. So essentially, fp_all is a pointer to that data structure called file, all capital, which is a reference to that. Okay, so now we're actually coming here. Why do I worry about this program called fseek? Fseek, the first argument is fp_all, and then the second argument is 0, and then seek set. Okay, how many of you have ever used the call fseek? You? Okay, can you actually tell us what fseek is doing? Okay, thank you. So to understand fseek, by the way, Unix environment, we just do man fseek. Okay, so you can see that this is the main page. It gives you fseek, a bunch of file for you to do rewind and things like that. And it has everything. And then here they have a description over here for you to actually read it. But of course, some of them are not that friendly. By the way, some of this instruction was actually developed in the early 80s or even middle of 1970, because this function hasn't changed since the beginning of the thing. So I actually want to tell you a little bit about fseek, because this is an important concept. So when you open a file, let me ask you, when I use the word file, how do you actually describe what is a file? When I use the word, it's a file. Piece of paper in the folder. Okay, great.
Single element, or the single element that you
Uh-huh.
doesn't have to be a text with the input. That's just it's a single element that you
Okay.
can process. It's even it's not a text, you could access it as a binary file.
Okay. Any other answer? Basic element to do the storage. Okay. All right, good. I mean, all the good answer. I'm going to give you a more of a computational answer a bit later. Can I ask another question? What's your definition of byte? B-Y-T-E, byte. What is a byte?
So
That's a bit. 0, 1 is a bit, right? What's a byte?
the unit,
In the back. 8 bits, right? 1 byte is 8 bit. A bit is a 0 or 1. That's the information per bit. It's a 0 and 1. It's called binary bit. But when you have 8 bit together, we call this a byte. So let me actually just make sure that you actually understand a little bit about history about the byte. Why do we think we care about byte? Why is 8 bit? Why not 6 bit? Why not 16 bit? Why is 8 bits? There's a reason for that. When the computer was first introduced, we're so interested in something called character. Because we want to write text. A to Z, capital, A to Z, lowercase, and then we have an equal sign, we have star, we have all kind of character, right? How many characters do you think we have? Go for it. It's actually a little bit less. It's 120 something. It's called ASCII character. But 4 bit is not enough. 4 bit is what? 4 bit. If I have a byte of 4 bit, that's actually 2 to the 4, which is a 16. By the way, if you're a computer science major, you realize it's important. Everything has to be power 2. Everything has to be power 2. So 4 bit is not enough. The next option is 8 bit. So 8 bit or byte is represent the basic information. I can represent a character. I can represent a lot of things. I mean, you talk about video. The video, everything is also 0 and 1, right? And then I can actually chalk every 8 bit. And then basically each of this is byte. So that's why sometimes you say, well, how big is a video? Oh, this video is 265 megabytes. Or this movie, I mean, a DVD movie is probably 4 gigabytes. You heard about gigabyte, you heard about megabyte, kbyte. That's actually why we use the word byte. So essentially what we're saying, whenever you say it's a byte, it's 8 bits. You times 8, you know that how many bits that there. Okay, so let me actually now we're clear about what's the concept of byte. Let me actually tell you what's the definition of file. A file is just a sequence of bytes. Just a sequence of bytes. And what is the sequence of bytes for? We don't know. This could be for video, this could be for a text message, it could be for a JSON, whatever, but it is actually a sequence of bytes. Yes, please.
In that definition, you say a specified number of a sequence of bytes.
What do you mean by the?
If it's just a sequence of bytes within a file, you would have a number of files. Because doesn't a file have like a file?
Right. But no, I understand your question. Thank you. Yeah. So I could usually I said a file is a sequence of files. But the thing is, usually I will associate with other attributes to this file, for example, file name. I have to put them in a particular position in the directory. By the way, that is the topic you will get covered in full detail in ECS150 to actually teach you how to actually do that representation. So when you actually go through that file system, which means that you click on this folder, you see a bunch of entry. When you actually try to open that file, then your relationship with that file becomes a sequence of files. But the thing is, before that, there's a lot of attribute or property associated with that. Yeah, that's an excellent question. Thank you. All right. So when the computer deals with that, okay, now I know my question. You see that I have a tool call. One is called fopen, one is called fseek. So fopen is really open what? The file name, the mode, when I open the file. But once the fopen itself is successful, then what I have is a relationship to that sequence of files. For some reason, I'm actually feeling I'm teaching operating system right now. But anyway, all right. So, but anyway, that is important for you to know what is a file. After you do fopen, is basically a sequence of bytes. All right, so I'm actually going to tell you what was okay, let me actually use example to tell you why the sequence of bytes matters. Okay. When I watch a movie in Netflix, or I watch a movie in DVD, do you know how I watch the movie? I mean, there are just too many contents there. So I usually what I did is I watched the first 2 minutes of the movie. And I fast forward all the way to the end, watch the last 2 minutes of the movie, maybe even the last 30 seconds. And then I decide whether I want to watch the rest of the movie. Okay, that's me, okay? So, by the way, how should I do that? If you think about a file, I'm actually looking at the sequence. Sequence means I have an index. I look at the first few indexed bytes about what's going on in that movie. So maybe it's a 007. What's the latest one? The movie that James Bond has a daughter. You watch that movie?
No time to die.
Yeah, No Time to Die. It was a fantastic movie. So the thing I look at the beginning, I look at his girlfriend betrayed him, and then at the end, he was say farewell to his wife or his daughter. That's I'm not supposed to spoil. I'm already become spoiler, right? I mean, my daughter hates me when I did that. Okay. Anyway, so I actually look at that. So what I did is I look at the first few bytes in that sequence. And I actually move forward to the end to watch the last few bytes. And then I will be able to do whatever I want to accomplish. So essentially, the reason I said, wow, a file is a sequence of bytes, that means you can actually control that sequence. You don't have to look at the byte one by one, but you actually have a way to actually choose where you want to start it, in the middle or in the end, because that's actually efficiency you want to have when you actually control a lot of information. And that function to do that is called fseek. Fseek is allowing you to switch the pointer to the file to the exact position you want to be. So fseek actually take a 3 parameter. The first parameter is actually the pointer of the file that I want to deal with. And then the third parameter talk about what do you want to do with that. Seek set means I want to set the location I want to interact with the file. So this is important. You don't have to deal with a file from the beginning. You can actually set anything you want. And the third parameter is called, the second parameter is called position. So over here, I actually do the position 0 because I want to begin from the beginning. By the way, why I have to do that? Because other place in the program, they might actually set it to somewhere else. So in order for me to make sure that I'm actually dealing with this correctly, I actually use fseek. Fseek, FPO is a file pointer. I set it to be 0. I want this to be 0. Let me just show you the original code, why I have to do this. If you do fseek in the same program, sorry. You look at this. This code is actually not my code, it's actually their code. You can see that they actually skip. They try to play smart using fseek, and they use FPO, and then they set some of the character to a different location. Okay. So, okay, finally, I make a great accomplishment by, to the end of the class, I only make about 3 lines of my code right now. Okay. So I'm going to, why don't I take a break to, then we started in 10 minutes after 4 in this room. I will continue the rest of the code and then record it. Okay. Sorry about that. This is probably more than I expect. I will just, maybe I just pause recording. Okay. Okay. So over the break, some student asked me, what is this notation? Character star star 2 star. So I just want to explain very, very quickly. This is, by the way, is the tedious about the C pointer, and also C is so powerful, it's so flexible, but it's not really, really, how do I say that? Programmer friendly, if you don't know what the semantics. So this is actually the way to parse it. When I say character star star, that means the first star represent is a pointer to a character. And then I add another star, that means that is a pointer to a pointer that to a character. So instead of a pointer to a character, it becomes pointer to pointer, and then pointer to the character. That's why I have this character star star. And you can do how many star you want, that's fine. Okay, in this particular sense, why I use character star star here as the result. I should actually try to tell you that, because what is a result? Result is a bunch of what? Is a bunch of candidate string. Each of the string is a character star. Remember, character star, which is a pointer to a character, and equivalent to character array, and equivalent to a string. That those 3 things are actually, we represent syntactically the same in C using character star. But in this case, I actually want the result to be not just one single string, but is actually going to be an array of string. That's actually helping me to actually get all the candidate, but sometimes a candidate could be, the number of the candidate could be enormous. So therefore, what I have here is a character star, which represents one string, and then I add another star to represent, I have an array of pointer to the string to actually help me to represent all the candidates. So that's the reason why here I use character star star. Okay, just let you know, for those of you who unfamiliar with the C pointer, that's actually sometimes, I mean, using, by the way, using C++, the chance we need to use a character star star is greatly reduced, because C++ actually offer better interface. That's why you don't need to do that. But if I actually lock in the C, so what I want to tell you as a student is just, this is really not encourage you to use this in whatever you're programming, but instead you learn this because you might need to understand somebody else represent the data structure this way. Okay. All right, so I have this fseek here. So fseek basically allow me to move around of that movie or look around with that word. By the way, how many words we have? Let me just go over here. If you come over here, This is the list. This is the file called all.txt. You can see that those are the legitimate 5-letter words. And so many of them. So essentially, when I try to find candidate or try to do elimination, I need to actually go through every single word that in this file for me to decide whether this is something which is consistent with whatever word I want to guess. Okay, so I want to just a very short moment of a Unix tutorial. So if I have a file, how many, you see that there are a line, right? Each of this is a line. So, okay, I want to tell you that I said the sequence of bytes. I do want to say that there is ARRET in this example, but there is a one hidden byte. You didn't see that in the terminal normally. That is actually a new line. Okay, so in fact, this line has 6 bytes. ARRET, and then there is a \n or new line, which is embedded there. That's why when it displays, it looks like this. Okay, so I'm going to teach you a command called WC. WC stands for word count. It counts in this file how many words you have. So it's actually telling you that this line has about 12,946 words. And the total number of bytes is actually 77,681. Okay, if you do ls minus l, you actually will see a similar number. You see that? When you do ls minus l is list, but minus l flag is give you more information about the file. And that file, all.txt, has about 77,681 bytes. Okay, so WC is actually a very useful tool in Unix environment. So I know this file has about 12,946 words. So I know that's the size of the words I need to deal with. So essentially, Wordle is doing is how do I quickly eliminate as many as possible among that 12,946 words, and such that I reduce the candidate and I will be able to make a much higher quality guess on my next guess in Wordle. Okay, that's the game about Wordle. Okay, any question before I move on to the next few lines? All right, so now this is a main loop. So let's actually look at this. What I did is I set the FP all to be beginning. So I actually basically move to the beginning of the movie or beginning of the sequence of the file. Now I'm going to do something. And then this while loop, I don't know, let me just go ahead because a while loop I think is universal. Pretty much all the language has a very similar structure. So I actually used another call called fscanf. Fscanf. Essentially what I did is I read from the file about a string. So I have to parse this. How many of you have used a scanf? Okay, some of you have used scanf in C. If you did C programming, you need to use scanf. So scanf is actually reading from the standard input, which is from your keyboard, the input. So we have a two variety of scanf. One is called fscanf, one is called scanf. So let me actually just do this very quickly. Man scanf. That's basically, oh, you see that? I have a different kind of scanf. I have a scanf. I have scanf, which is scanning a string. And then I have a fscanf, is scanning a file. So the thing is that all of them is actually scanning a sequence of bytes. That's why the concept is so universal. No matter how you do with scanf, it's actually scanning a sequence of bytes. A file is a sequence of bytes. A string is a sequence of bytes. And your terminal input from your keyboard, that's a string of bytes that you are entering. So that's why this three function, scanf, scanf, and fscanf, they have exactly the same structure. They always look for the string of bytes, but it's a different source. Fscanf, you're actually reading from the file. S, reading from a string. Scanf, just reading from your keyboard. It's the same concept. Okay. Now I want to go through this line. I actually go through this part first. Fscanf. This part, you see what I did is that fscanf take essentially two parameters. The first parameter is a file handle. That's why FPL, our good friend. And the second part is what we call format string. This part is called format string. Format string is basically saying that what kind of things you're supposed to scanf in. And in this case, I actually using a format string that's actually, let me ask a question. For those who are in ecs36b, do you know, have you ever seen the usage of a format string like this? What I did here. Anybody know what that is actually indicate?
Regular expression.
Yes, it's a regular expression. What's that regular expression? That's good.
And then that ends with the backslash n.
Right.
So just work until final.
Right. Okay, good. You actually know regular expression. That's great. For those of you who don't know the term regular expression, you will actually learn the term regular expression a bit later in the, you're a graduate student, right?
No, undergrad.
Undergraduates, wow, which course you learn regular expression?
On my own.
Okay, see, you're good, you're good, thank you. So regular expression is something you will learn in later course in computer science, which is a very important concept about how do you actually represent a representation in any kind of string or character. But the thing is that for those of you who actually know C or know Java, you probably know you can do something called format string like a %. %s, that means is a string, or %d is a decimal, %f is a floating point. But then I'm actually using a regular expression here. And by the way, this is a very useful. I use this a lot. I use this actually more than pretty much anything else. This regular expression is very easy for me to match exactly the things I want. So the way to specify regular expression in the format string, the first thing is still this % sign. This % sign is so crucial in the information you try to capture. So once you provide that % sign, the compiler is going to interpret the next few characters, try to interpret as the format string or as the regular expression. If you have this, what you call the bracket, okay? So the way to interpret, let me actually use a line to actually interpret this. So here you can see what happened. So the format string is with this % sign. And then you have this pair of bracket. And the pair of bracket represent what kind of character I'm trying to match. What kind of character I'm going to match. And then this sign in C is called not. It's actually a negation. So which means that whatever character you say after that negation is the character you don't want to match. So essentially you see what's a character? \n, which means that I'm actually going to swallow everything in the scanf, the file, until I hit the first new line, \n. So remember, what the file looks like? Yes, it's the word on each line, but remember I said what's actually hidden. there is a \n at the end of that 5 character because it's a new line. So essentially, this is going to match. If I'm actually heading this line, it's going to match A, and then L, IJ. Let me actually print it out very quickly. Let me actually write a simple program. Okay, I'm writing a very simple program to do everything I just talk about. So I have a file called star fp all, and I said this is going to be. I look for Wordle. OS. I want to see that open. Here. What I did is I actually just let me just summarize what I did so far. So I actually opened the file. I'm using this one. And then what I did is fseek. Over here, I do a fseek. I'm actually copied this buffer as well. Okay, I do a fseek, and then I do fscanf. Exactly, exactly. So then I just do this. And then I just do fprintf. I print it out stder buffer is equal to %s \n, and then buffer. And then return 0. Okay, so I'm actually trying to bring the code into, I open it, and then I set the buffer, and fseek is actually, in this case, it's not strictly necessary, but I want to put it there. And then you see that I actually try to scan the search something until I hit %s, and then now let's actually try to run it. By the way, this is so in learning programming, it's usually let's just try to run it and write a small program to verify the concept. Oh, I have an error. Oh, FPO. What did I do? FPO. Oh, I know what happened. It's a case sensitive, so it's lowercase. Okay. Okay, so you see that I actually got the first 5 letters. AHED, if you actually go to see lists. Oh, thank you. See, that's the first character. Okay, so actually let's try to do this. Let me actually try to change this a little bit. What happens if I do this? If I do it twice, to do fscanf, fprintf, fscanf, do it twice. Let's try to run it. What do you think we will get? Go the first two words, right?
This, the first word was, is I reset it to 0.
Let's try to see what happened, okay? In fact, it will be only the first word and then nothing. Oh, okay, that's right. The first word is actually indeed both of them.
Gives it the pointer every time you open the file and you.
Let me actually check my code again. Let me check my code again. Doesn't. F-scanf. Huh, this is actually kind of unexpected. But anyway, I'm actually going to do this. fget_c, fp all. If I do this, fget_c. Now I'm getting two words. You see that previously, when I don't do that fget_c, I actually getting this. But when I do fget_c, I actually get to the next word. You know why? What is fget_c? fget_c is getting the next character out from the string. What's the next character? After I get the first one, what's the next character? It's a new line, right? Remember I said there's a new line, simple, that's hitting there. So when I do fget_c, I'm actually getting that new line, simple. And there is a trick. You can actually be able to view the new line character, but I'm not going to cover that today. Yeah.
So if you're on new line after fgetc, wouldn't the second scanf function just stop because it
Right.
said not new line? So why would it
Right.
go to the next word instead of just stopping there?
You're talking about the. Sorry, I try to understand your question. You're saying that with or without this particular line?
With fgetc, once it finishes the fgetc line, it is on the \n parameter, right?
Once they do fget_c, fp all, it actually get that character out of the string. So essentially, remember we have a pointer to point to the string, the mains. At the end of the first fscanf, it actually stops at the new line simple. When you do fget_c, it actually move one character next.
Okay, so
Go to the second line.
Okay.
Yeah, that's why fget_c is actually important. If you don't do this, then you kind of stuck over there. Okay. I mean, for those of you who hasn't done this kind of files, could be a little bit challenging. But by the way, this is very important capability for you to be able to handle the file this way, to understand. I mean, the file is a sequence of bytes, but some of the bytes is new line, some of the bytes is actually some kind of strange character. So to handle the bytes, we have to know what they are, what kind of function we need to handle. Okay. Any question? Okay, so I will upload this program as well. This is just a very kind of take the most important function related to the file out of that program. I just put it here. Any question for this one? Okay. Let's actually go back to the code. All right, so we're here. fscanf. That's a line. We're going to get this buffer of this. And then you can see I actually put at the end of the while loop. You see that I have fget_c here. That's why I need the fget_c. I have that fscanf, but at the end of the loop, I always do a fget_c to get rid of that character so I can move to the next line. Okay. All right, now let's actually look at the inside of this. So you can see that what I did is that, okay, the other thing is important is that fscanf actually has a return value. It always returns the number of bytes you actually read from that. Let me actually modify this. Let me actually modify this. Is a number of bytes you actually just read. For example, I say integer byte count. And then I said BC is equal to fscanf. Okay, so I just remember how many bytes I got. And then at the end, maybe at the beginning, I just print BC is equal to how many percent D? It means that how many bytes I actually got from that. So let me actually try to compile it. Now you can see what's doing. What? You don't like my percent D? Oh, I'm sorry. I forgot to say something. BC. fscanf. See, I think this should work. What happened? Did I miss something? Expect error. Okay, I make a mistake. Line 45. What did I do wrong? Okay, that should work. What did I do? Must messed up with a character somewhere. My editor has some issue. Line 90. Line 90. Sorry, line 90. Let me actually do this. There is a function because called diff. I want to see what I did wrong. Wordle.c and the Wordle. You see this? I must make some mistakes somewhere. I'm going to redirect that to the different diff.result. More diff.result. Sorry, I did something which is I'm not supposed to. And so this part is everything is here. Like this, character alphabet size. Previous. Yeah, that's not good. Let me actually try to fix it. Okay, I'm going to do something very quickly. I'm missing a few things. So sorry, I have to introduce this back. I think I messed up with some of the characters, so now I have to re-inject into this. Okay, this should work now. Let me try to compile it. Okay, so I'm sorry for the delay. I was making a mistake in editor. So if I say new, it's just no, doesn't show the behavior I would like to show. Okay, anyway, I'm going back to fscanf. Okay, so when I print the number of BC fscanf is actually, suppose if the output of the BC is actually EOF, represent as end of file, then essentially we know it's actually finishing reading the whole file, then it will jump out of the loop. Okay, so that's the things here. And then within here, let me actually tell you what I did here. What I did is that I go through all the words you just enter. Buffer, remember what's buffer? Buffer is the word I actually just get it out from the file. And what I did is I go through every single character in the impossible. Means that what is impossible, just try to recap that concept from the previous hour, is actually keeping which character is impossible to be in the file. So over here, I'm just iterate through every single character of the word I just read from that file, and then try to compare that against impossible. If there's anything character that's matched, and I know that word need to be eliminated, so that's why I flag the one, flag the word to be one. So essentially, you can see here is that if the flag is equal to 0, that means this word is still in the candidate set. And then I actually call the other function called check filter word. I'm actually checking some other perspective. In this case, I'm just checking whether the position related property in this file. So this loop, if you actually finish the checking this, at the end, you will see that if the check is actually 0, that means that the character is all in the word, all the character is actually valid, is still valid. Then I actually basically record that word into the result. And at the end of the program, I just return the result to whoever called this function. And then the result is going to be a sequence of words that's actually still valid. So this is the function I want to show you. It just, this function is called, what's the name of the function? This function is called filter words. So essentially go through every single word in all.txt. And it has the input is the impossible. So essentially this is going to eliminate all the words. That's actually impossible to be the solution. And as you build up the impossible by each of the guests, then essentially you will be able to filter out more and more words. And eventually just remember how I run this program. Let me actually get rid of that BC stuff because this is not accurate. So when you do new, it actually, for example, this word, it actually filtered down to this 4 or 5 words. And if it actually filter out until you have a 1, then you're basically done, get the solution, okay? So that's kind of the general strategy and some of the programming segment for you to actually consider to solve this program assignment number 1. Any question? Yes.
Like the ideal like solution like for this programming assignment is like is it gonna have like all the guesses that narrows it down to like on the screen and then you choose, or is it literally just gonna like be an algorithm that finds the correct one?
I would say just find one. Go all the way, find one. You don't need to read the math. Correct. This is not a solution, it's just a partial solution for you to see the idea. Yeah.
So the end result should not have user input at all.
Yes, it should not have user input at all.
So would we be,
By the way, you can program some of the input yourself. For example, we say the first word is say, what was the word? Yeah, whatever word you choose, you can actually hard encode that into your, especially for the initial word, right? The initial word is very important because it helps you to quickly eliminate a bunch of files. I mean, let's actually start to look at these things. Let's do this exercise. Can you guys come up with the 3 5-letter words? 3 5-letter words. It covers 15 different characters. Oh, you're expert in this. Let me actually put it in the code. Wordle ECS. Okay, what's the word? Okay. Now we have another expert in this room. So the first word should be Earth. What? M-O-U-R-N? M-O-U-N-D. Okay.
And the last word is
S-I-C-K-Y. That's clever. I'll start using the 3 words. Yeah. Okay. So that's good. You see that this is a 3 words with 15 character. It's actually already took care of a lot of, it helped you to do a lot of elimination, right? So essentially you can actually just program this regardless what happened. You just enter this first guess, the second guess, the third guess instead. I mean, okay, now I'm going to give you a challenge. Do you think you can come up with a 4th word with another 5 character? Maybe cover another 4 or 3 character?
I don't think we have any more vowels.
No, I said we can cover 3, that would be fine. So 4 words, we cover 18. That's actually pretty good. Any more vowel we can use? Yeah, A, E, I, O, U. Yeah, it's actually all of them are here, even in the Y, right? In fact, it's very interesting. I found out there are words without any of the vowel. Do you believe that? We could have a program, we could have a word without any vowel. Do you think that's possible? Can we write a program to do that as a conclusion for today? Okay, I know I want to do this. Check. Sorry. What's the program? Filter. Okay. I'm actually going to do this. I think I have seen this when I played the game. I'm going to use this function. I'm going to copy this function over here. Okay, I'm actually going to do this. I'm going to make this pointer global. Okay, this is a file pointer. I have a filter words. I'm actually going to make this simple, so I'm going to do void. And then the impossible should be the same. Impossible should be the same. This part, I don't need a result. I'm getting rid of that, so it will be simpler. Result count. I don't need BC. I'm still doing fscanf. Okay. This looks good. And buffer I impossible. If this is the case, I don't need this one. I don't need check. I will just directly print the buffer word if it's a flag is 0. Okay. I think I got everything I want from here. Return. This is just return. Okay, and what's the name of the function? Filter words. And I'm actually going to, I don't need to do this actually. I can get rid of this. Filter words, right? And then what's the filter words? That's actually is a string. So I'm going to do A, E, I, O, U, Y. Is that all the val? Is that right? So the impossible I input is actually a string. And over here, I just say return. Because the rest is, I want to keep it there just for you to learn the code. Let me actually try to compile this program. Okay, return null. Why I have impossible? Oh, okay, I know what happened. 11, line 11. Okay, impossible, then is return. This is return. Still have a one arrow, string length. String length. I should include string.h. So that's the arrow probably just because I didn't do. Let's see if this helps. Okay, the last one is line 47. Line 47. Yeah, I think that's fine with me. Okay, this is fine. Return here. Oh, I know. Return 0. Sorry. Okay, so if I do a out, you see that those are the words. What I did is I wrote the program. My impossible is A-E-I-O-U-Y. And then they actually get down this 5 words. They are valid words in the all.txt, and they don't have any val. That's actually interesting, right? 5 letters and but I just want to show you that there are words that actually doesn't have a val. The second thing is that how do we actually write the program to validate that? I actually know nothing about any of this word, the meaning. Anybody know? Anybody know the meaning of the words? Anybody from literature or linguistic major here? CRWTH. I'm just curious. I want to see what is the meaning of CRWTH. Yeah, that's an advanced question. What's that? CRWTH. Okay, how to pronounce, pronunciation, right? You see that that's a very popular. Everybody is actually. How do I get rid of this? Is this an advertisement? Oh, the
in a national park. And it's where I met up with Cass Meary, one of the very few capable performers of this intriguing ancient instrument, the crwth.
I missed the first part, right?
At the 12-second.
All right, let's try again.
Special guest, the Welsh crwth.
Crew.
Hey.
Hi, this is a Welsh crwth I'm working on at the moment.
That's amazing, right? So you learn other than programming in this class, okay? Me too. All right. Any other question? All right. So I will just show you what I did here. Is hold on 1 second. So the last program I did, I thought is interesting is I have a program called filter words was impossible, and then you can basically put in anything you want, and just try to help you to get rid of the things you don't like. And in this case, I just basically get rid of A, I, O, U, Y, and then develop the strategy. You can do whatever you want. Just make sure how do you eliminate quickly. And we are going to change the code if you missed it. Instead of 6 guesses, you just guess how many times you want. That's your choice, okay? Yeah, I will post all the video and the code on GitHub, okay? All right, I will stay here and for a couple of minutes, and thank you for your attention. Just 1 second.